Okay, laws of logarithms. We, I'll be honest, y'all are probably going to think these are just kind of goofy and why. There are a couple reasons, but the main reason I'm stressing them to you is that in calculus on the AP exam, there are some multiple choice answers that they have used the laws of logs. They are not difficult. They might be a little difficult to prove, but if I have the log base anything, doesn't matter. Could be a common log, could be a natural log of two numbers that are multiplied together. That is an equal marks, but it is also like, this is logically equivalent to the log base a of m. Guys, when we have exponents, a to the m times a to the n, what do we do to those exponents? You add them. This is the log base a of m plus the log base a of n. So if the directions say compress or whatever the log expressions into one single logarithm, we're going to go this way, right? If the directions say to expand, then we're going to go the other direction. So knowing, I'll switch from printing to cursive. What do you think we're going to do for the division? You're going to subtract. Exactly. Any questions about that? It literally, and the same thing, like a to the x divided by a to the y is really a to the what? X minus y, yeah. So remember, we can turn any log into a what? Any log form, we just practiced it. Log form can be converted to exponential form, right? Now, this one is a little bit weird. Log base a of x to the m is logically equivalent. In other words, if I start out here, I can go that direction, or if I start here, I can go. An exponent actually becomes a coefficient. So these are the main rules of logs. If we have an exponent, it can become a coefficient. Have we talked about this one at all? I didn't think we have. Now, so in application, there are occasions that I could actually use a rule of log to figure out, like, let's say, what is the log base 2? Sorry. The directions here would say evaluate. The log base 2 of I think I'm going to make it 4. Sorry. The log base 4 of 32 plus the log base 4 of 2. Do you have any idea what the log base 4 of 32 is? No. What's the question you ask yourself for this? What power of 4 gives me 32? No idea. Now, you see why I changed it. If it was log base 2 of 32, what would you say? 5. But log base 4 of 32, I have no idea what it is. The log base 4 of 2, now, the square root of 4 is 2. So I think I could come up with 1/2 for this one, okay? I could. But What do the rule of logs say we could combine this to be? 32 times 2 is 64. Do what we have a power of 4 that gives us 64 now. Yes, it is 3. So, sorry. In one aspect, we can use the rules of logs to actually evaluate some. I'm not making it log base 4. I'm going to make it a common log. What does common log have as its base? 10. So use a rule of logs here. What do we got? Log base 10 of 100. What's the question we ask ourselves here? What power of 10 gives me 100? 2. Done.
He's on his phone? Were you on your phone?
What about common log of 2,000 minus common log of 200? Do you have any idea what power of 10 gives you 2,000?
No.
No. Or what power of 10 gives you 200? No. But if we combine them, subtraction turns into what?
Division.
What is 2,000 divided by 200?
10.
It is 10, isn't it?
Yeah, because there's only one accuracy.
Yeah, this guy gets it.
And what power of 10 gives me 10?
1.
Oh no. So that is the short list of things that it could help you evaluate. Other than that, we're going to work on just 2 sets of directions. Well, actually, a third one. I'll go ahead and show you the third one, and then I'll do there. It's called a change of base formula. And honestly, after next class, I will actually be able to show you why this works, but I'm not going to prove it this time. But the change of base formula says the log base anything of x over y. I'm sorry, of x. Equals either the natural log of x over the natural log of a, or the common log of x over the common log of a. Now, on the TI-84s, there actually is in the catalog somewhere, in one of the, it might be under math somewhere, that you can actually change the base and find it. But if you use this, it's just so easy. Question?
Log, or natural log is just log base E, right?
Log base E. Beautiful. Thank you.
High five.
So if I ask you to evaluate log base 3 of 6, I don't know what that is. Just, I could tell you a general, did you say 1 point what?
5.
I'll say 1.5 is a decent guess. I might go 1.6. Why do we know it's between 1 and 2?
Because
Log base 3 of 3 is 1. Log base 3 of 9 is 2. Yeah, log base 3 of 9. 3 squared is 9, right? So we know it's somewhere between 1 and 2. Let's show where the natural log of 6 over the natural log of 3 is exactly the same as the common log of 6 over common log of 3. I'll show them both. Natural log of 6. The biggest mistake people make is they forget to close the parentheses. 1.631. Let's show it with the common logs. Same exact numbers, right? 1.5 was pretty daggone close without a calculator. 6309.
Yeah.
Yeah, it was only a tenth off. That's not bad. How about the log base 5 of 75? What are we going to plug in chug? Natural log 75 over natural log 5. Whichever one you want to use. I don't know why I always choose natural logs.
What if you do and just do some random?
Hey, does it make sense that the power of 5 that gives you 75 is something over 2, but less than 3?
Yeah.
What's 5 squared? 25? What's 5 cubed? 125. It's got to be between 2 and 3. Yeah. Oh, you would have the calculator for it. Oh, let's see if we can find... Y'all see a log base anything? Oh, there it is. Log base. See the log base 5 of 75. Same answer. To me, it's just as easy to do ln of 75 over ln of 5, isn't it? Than to try to find that log base thing. All right. So now, the two sets of directions where we're just using the laws of logs. The first one says to use the laws of logs to expand the expressions. So, you may be given a log base 3 of 4x squared y, and we want to expand that. Well, the first expansion is going to be from the multiplications, right? What would that equal? 4 plus log base 3 of x squared plus, so I expanded it over the multiplication, right? That makes sense. Is it fully expanded?
No.
That power needs to become a coefficient.
Oh my goodness.
That would be as expanded as we could go. All right, so, yeah, we have people listed, Abe, or A times B times E. And this E, by the way, is the base of this natural log, right?
Yes.
So, what does that square root mean? The power is what? 1/2. So, maybe a little rewrite. This would be good. Now, can we split up over the addition first? Or what must we take care of first? the power thing, right?
Would it go on all of them?
It would go on all of them, or leave it outside parentheses if you want. And at this point, I'm gonna say, go ahead. I mean, you'll get really good at this, people, okay? You'll get really good at realizing, oh, that 1/2 comes down. Now we can split up over the multiplication, correct? But I would propose that if you had like a common log of 10 or a common log of 100, I would propose, what is this really? Yeah, the power of e that gives you e is 1. And if we want to distribute the 1/2, we could call it 1/2, couldn't we? I really have issues with a non-cursive. I'm making my B, I'm taking a stand.
Your B looks like the L.
Oh, hush, it's cursive. So let's do one that is just like hugely big.
Oh, so that's it.
Common log of 10 to the x over x times x squared plus 1 times x cubed plus 2. Now, this is x times x squared plus 1 times x cubed plus 2. Now, what do we have to take care of first on this one? The division, yeah. Division turns into subtraction. Now, where does the subtraction go?
You need to put it in parentheses.
Yeah, you could either put it in parentheses, or you could say all of those things are divided, right? So we could just distribute the parentheses if that makes sense, right? Are we fully expanded yet?
No.
And by the way, I'm going to say expand it and simplify if possible. That power becomes a what?
That becomes
A coefficient, right?
in log.
Question.
Yeah, so like they're divided, so you would subtract them.
All of them, yeah. What he said originally was, we could put a subtraction and a grouping symbol because they are multiplied together. But what does a grouping symbol do with the subtraction out in front? Distributes it, right? Either way, however you want to write it, just understand, if it is in the bottom, it must have a subtraction out in front of it.
Can't you?
And what is the common log of 10? Yeah, the power of 10 that gives me 10 is 1. So if there is a simple simplification like that, guys, can I tell you the part that always gives me a little pause? That. I want to try to do something with that plus. You can't. You just got to leave it all grouped together.
Oh, you can't even take the exponent?
You can't do, yeah, you can't take the exponent out because of the addition or subtraction in there. So this is as far as we can go
Well, then I was done.
You can't do anything with it either.
with the subtraction.
Like if it was a like x squared minus 1.
Yeah, yeah. If we made that a -2 or whatever, it would, yeah. Now, the last set of directions, or the next to the last set, because the last is doing the change of base. Combine into one log. Logarithm.
So is it just the opposite?
It is just the opposite. What's this going to be? Actually, I think I'm going to do this. I'm going to throw a curveball. A squared minus b squared.
That's
All right, so what is this combined? So And simplify again if possible.
A plus B over A squared minus.
The subtraction turns it into division, right? A plus B over A squared minus B squared. But if this was multiple choice, well, I would say just factor the bottom. What does the bottom factor into?
A plus B minus B.
So what happens?
It's natural log.
So the simplification would be natural log of 1 over A minus B.
Genius.
I did it. Can I go to the bathroom?
Yeah. Uh-huh.
Including square braces.
Guys, the question is, can't we do something with that exponent? What was the answer?
No.
Because it is grouped together. That is the biggest mistake I have made. I want to try to split those up somehow or do something with it. And you just can't. If it's grouped together, if there's something added or subtracted in there, we got nothing to do. That's as far as we can go. So 2 times log base 5 of x plus 2 log base 5 of y minus 3 log base 5 of z. All right, guys, what should we do? I'm going to suggest we don't try to turn these into exponents yet because we have a 2 outside of the big parentheses. So we need to distribute that first. What would this become? 4 log base 5 of y. Back row, what would this last one be? Now what do we got? And you will get so good at these that you will be able to do it in like one more step or whatever, but I'm showing you. Turn this into an exponent, right?
What's over there?
What is that noise?
Is it the game? The game? Oh, right there.
No.
So now, what does the addition and subtraction turn into?
Multiplication.
Yeah, the x squared is multiplied by the y to the 4th, z to the 6th. Now, I had to, in the last class, I had to prove, well, it looks to me like this z to the 6th is only being divided by the y to the 4th, correct?
Yes. But there.
But
there.
if I'm multiplying that by an x squared, that is an x squared over 1, correct?
Yes.
So the x squared would stay on top and the z to the 6th could be on the bottom of the whole thing. Just because that's how multiplication works. Any questions? That's pretty much
That's it.
it. So I